Okay, yeah, I think I can start for today. So, okay,
Yes, please.
okay. Um, can everyone see my screen? Okay,
Yes, we can see your
yes.
screen.
Okay, great. Um, all right, so today we're going to be talking about universe and the Earth. And again, I apologize for um making you wait. Uh, yeah, thank you for understanding. But we'll get started for today's lesson. So let's start with the Big Bang Theory. So how did the universe form? You might be asking, what is the Big Bang? The Big Bang is the scientific explanation for how our universe began. So about the 13.8 billion years ago, the entire universe was much smaller, hotter, and denser than it is today. But then that dense material suddenly began to expand, and the universe has been growing larger ever since. So what started as this small, dense place started to expand. And many people imagine that the universe exploding from one point, like a bomb. Right? And the Big Bang was not really a giant explosion that threw matter into empty space, but it was the rapid expansion of space itself. So as the space expanded, galaxies started to move farther apart. And to see how the Big Bang started, we can look at this short video. It'll explain how the Big Bang is this giant explosion at the beginning of a universe and how it expanded to create other galaxies and our planet as well. So let's look at this short video.
Make smart.
Yeah, so that video talked about, well, from the start of the Big Bang until um, to the creation of the Earth. So as we have seen, it was this giant explosion in the beginning. It's a theory that a giant explosion caused the formation of particles, of atoms, and it started forming stars. Okay. Mhm. So yeah, I hope you were able to see the video. Okay. Um, yeah, so basically the video talked about the creation of the universe, starting from the Big Bang Theory, how everything formed and expanded due to a big explosion in the beginning of the universe. That was the Big Bang Theory. But what happened after the Big Bang? As we have seen, the first moments were that the universe was extremely hot and tiny particles were formed. We've seen the nuclei forming and atoms forming. So at first, there were only tiny particles. A few minutes later, or maybe a few years later, you know, the hydrogen and the helium were created. Those atoms were created. Right? And then more hundreds of millions of years later, the first stars were born. It started creating galaxies and stars within those galaxies as well. And that includes our sun. Our sun is a star. So it also created our sun in the process. And billions of years later, galaxies, planets, and eventually our planet Earth also formed. So this is the sort of our key timeline um, after the Big Bang. Well, that's according to the Big Bang theory. So these are the moments, yeah, after what happened after the big explosion. Okay, so again, there was this giant explosion in the beginning. It formed particles and dust. Um, it was very hot. It formed very hot gases and particles, and then those formed atoms again, and stars. Right? They formed stars and planets as well. Stars and planets. And the universe is also constantly expanding still. According to the Big Bang Theory, the universe is still expanding. Okay, now let's move on to the stars. So, what are the stars and what are they made of and how do they work? A star is a huge ball of hot gas in the space. It produces its own light and heat, and the sun is the closest star to Earth. So the sun that you see every day is considered a star. It's a star. And stars shine because of a process called nuclear fusion. And remember that stars are not forever. Stars are born from hot gases, and then they live by producing light and heat, but they eventually die. Stars can explode, um, and again, depending on the size of the star, it can either release the gases, or if it's larger than a dwarf star, it can even create a black hole. But we'll get to that later. But remember that the star is a huge ball of a hot gas, condensed hot gas. Okay. Yeah, so stars, if you look up at the night sky, during the night, if you look up at the sky, you'll see a lot of stars, right? Maybe not this much, but you'll see stars in the sky as these tiny, blank, bright dots, right? If you look up at the night sky. Um, yeah, those each individual dots are stars emitting their own light. So they're really, really far away, but you can see them because they emit their own light, and their light is reaching your eyes here on Earth. And this on the right is our sun, right? This is our sun. And our sun is also a star that emits its own light and heat that reaches Earth, right? By sunlight, we can feel the sunlight, heat, and light. Okay, so now let's bring down the lens zoom out a little further and look at the galaxy. Right? So, what are galaxies and how did galaxies form? And these are all different types of shapes the galaxies can take. So let's look at some more examples. So a galaxy contains millions to trillions of stars and gases and dust and dark matter and held together by gravity. By the central main gravity is by a black hole, usually. But astronomers estimate that the observable universe contains around 100 to 200 billion galaxies. So imagine how large our universe is, from 100 to 200 billion galaxies, and each of those galaxies has millions and even trillions of stars and planets. So the universe is very, very huge. Some galaxies are small, containing only a few million stars, but again, others are huge, containing trillions of stars. And galaxies can come in many different shapes, right? They can come in a spiral shape like this, can come in into an elliptical shape, or something else like this. Okay. Let's talk about our galaxy specifically, and it's called the Milky Way. Our galaxy, the Milky Way, is our home galaxy, and it's a spiral-shaped galaxy. Our galaxy is the spiral-shaped one, this one right here. And it contains an average of about billions of stars. And just for some facts, our Milky Way is 100,000 light years wide, meaning that if you travel at the speed of light, it'll take 100,000 years to cross the entire galaxy, our galaxy. That's very, very huge. But the speed of light is 300,000 kilometers per second. And know that one light year is 9.46 trillion kilometers. And imagine taking 100,000 years to travel. That's a huge number of distance, right? So what I'm saying is that the galaxy is huge. Our galaxy is very, very big. And our solar system is not in the center. We are over here. Can you see the dot here? This one. We are over here in our galaxy, over here. And this spiral arm, specifically, this part of the spiral of the galaxy, is called the Orion arm. This is called the Orion arm. And it is about 26,000 light years from the center of our black hole. And our solar system is basically a system that's containing our sun and our planets like Earth. It moves around the center of the galaxy. It goes all the way around, right? It does orbit, yeah. Galaxies do orbit. But it takes around 230 million years to make that trip. All right. So now let's get into what actually is at the center again. Like I've said, the center of our galaxy is the black hole, right? The black hole, which has the gravitational force to make the swirly shape of the galaxy. The black hole at the center of our galaxy is called Sagittarius A, and it is a very, very big. It's around 4 million times heavier than the sun. Yeah. And scientists know that it is there because nearby stars move very fast around it. Due to its gravitational field, you can actually partly see the Sagittarius A, which is a black hole. Again, remember that at this position, right, the Orion arm is here, you know, and our solar system is here, right? And the black hole is at the center. And it's pulling everything around it and creating an orbit, right, going around. All right, so let's finally get into what actually a black hole is. So a black hole is a place in space with a very, very strong gravity. And the gravity is so strong that nothing can escape, including light. So even light gets pulled into the black hole, and you can see this phenomenon happening. So when a big star dies, it becomes very small. It condenses into this very small space, and it becomes very heavy. Usually when a big, not a smaller star like our sun, but a bigger dwarf star explodes, then it becomes a black hole. And it creates this extremely strong gravity, right, pulling everything in, and nothing can really come out of the black hole. The black hole pulls everything in. And remember that the black hole is invisible to our eyes because light cannot escape from it. But scientists can find it by watching how nearby stars and gases move. So even if we can't see the black hole, you can see the other planets and stars getting sucked into the center. That's why we know there's a black hole at the center of our galaxy. Okay, let's watch this video. It's a short video explaining what a black hole is. So let's do that now. Yeah, so as we have seen in this video, yeah, it talked about the black hole and how it formed from collapsing from a big star, right? And everything gets pulled around it and how it functions, and even current research is not fully developed to find out information more about the black hole. So it is in active research currently. Okay. So that was about the black hole at the center of the galaxies. But now let's look into our solar system specifically. And again, remember, our solar system is inside the Orion arm of our galaxy. And this is just a small part of it, right? Solar system basically contains our sun and other planets, including planet Earth, our planet. Okay, so let's talk about the formation of our solar system. As you may know, the center of our solar system is a star called the sun. And the formation of our solar system started with the sun's gravity pulling in planets and rocks about 4.5 billion years ago. Those planets, in order, were Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. So Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Those eight were the primary ones, planets that originally um, orbited the sun. But actually, Pluto was considered to be a planet once, but it got expelled from the solar system because it was too far away from the sun. It was too far away from the sun. It didn't get affected by the sun's gravity a lot. So we don't include it as a planet for today. Now, yeah, so this is the picture that I wanted to show. So here's the diagram of our solar system. And it's good to know the order of planets from the sun. Like, what is the closest um, planet to the sun? And you can see it's Mercury, right? Mercury is the closest planet to the sun. And you can see the relative sizes from the sun as well. The sun looks small at a distance, right? The sun looks pretty small. But the sun is actually huge, right? The sun is this much bigger than the other planets. The sun is huge. But again, the order of planets from the sun is Mercury, then Venus, then our planet Earth, then Mars, then Jupiter, then Saturn, then Uranus, then Neptune. Again, very important to know the order. And also note that there are these belts as well, these asteroid belts. These contain a lot of space particles, asteroids, just floating around and orbiting the sun as well. So there is a belt between the Mars and the Jupiter, right? And a Kuiper belt at the end of our solar system beyond Neptune that orbits around the sun as well. So yeah, if you've written down this order, then yeah, that's great. I'll move on to the next slide. Yeah, tell me if you are finished writing down maybe the order of the planets. Oops. Yeah, yeah, okay. Just okay, great. If you're done, we can move on. Okay. Again, this is the order, this is the same part. But let's watch a video, short video really quickly. And that explains more about the solar system briefly. So do that now.
Hi there, I'm Lilypad. Let's play.
Get to know the Toy Story gang. Jessie is a rootin' tootin' cowgirl.
Yeah, so from this short video, we saw our solar system and some more information about each planet. Okay. So now let's talk about our Earth specifically, right? So let's talk about uh, our Earth form and how even did life begin on Earth, right? So Earth initially was extremely hot when it was first formed, and it was mostly molten, meaning that it was mostly at a liquid level, and it gradually cooled and it formed solid land, call them continents or plates of the Earth that formed the continents and the ocean. And land masses slowly moved to shape Earth's surface over time. And water formed during this process as well. And it became the most important resources um, to sustain life and to sustain the environment of the Earth as well. It's essential for the origin and the survival of life on Earth. So first it was extremely hot, then it cooled down, then water formed and life began to form. And this process is the Earth's evolution. So Earth, since the beginning, went through a lot of stages. Those stages are, like we've said, the hot start or the Precambrian eon. And that started around 4.6 to 4 billion years ago. The Earth solidified and formed 4.6 billion years ago, around 4.6 billion. And life started to form, the life beginning, anytime between 4 billion and some scientists say, 3.6 billion, but that is again up to debate. But life began starting from 4 billion years ago until 541 million years ago, somewhere between those times. There was also the age of animals, or the Paleozoic era. It started around 541 to around 252 million years ago. And then there's the dinosaur time, right? As you may know about dinosaurs, they existed in the Mesozoic era, which existed from around 252 to 66 million years ago, approximately. And then there was a very cold time on Earth called the Ice Age. And the Ice Age existed from 2.58 million years ago until pretty recently, right? Until pretty recently, until pretty present, there was this really high cold Ice Age stage of the Earth that existed for a long time as well. And again, our current era, or the sort of human era, started with the Cenozoic era from 11,700 years ago until today. So we are currently in the Cenozoic era. Um, and there's been multiple debates about whether a new era should be created now, but remember that humans were um, human development started from the Cenozoic era, 11,000 years ago. Okay, let's look at this video. It's again a short one, but this will explain briefly the Earth's evolution. So, yeah, as we've seen in the video, it kind of covered the process from the Earth's molten hot start until the present human era. So, yeah, that was a brief recap. And again, let's briefly talk through the stages of the formation as well. Um, in the beginning of the life, on the origin of the life on Earth, it began around again 3.7 billion years ago around with water present, right? Water present before and water and helped enable the creation of the life on Earth, alongside some of the microscopic organisms that formed. And these are one of the first life forms that formed, these microbes, this microscopic organisms. And they're too small to see with our eyes, right? But these early microorganisms, they were simple single-celled organisms, and each of them lived in the oceans, but they had a very crucial role in creating oxygen for Earth. It created a suitable atmosphere for Earth. So these early microorganisms were very important for the formation of life. So let's talk about, the oxygen and the Earth's atmosphere, right? So like I've said, microbes produced oxygen from carbon dioxide in the atmosphere. And over time, the oxygen built up. And this made Earth livable, made it available for more complex life forms that include the use of oxygen and more. So humans require oxygen to breathe, right? But oxygen started its production from the tiny microbes at the beginning of the creation of Earth. And after more life evolved to, um, insects, mammals, etc. But there was a time where dinosaurs um, were created, or organisms evolved to dinosaurs. Right? And the dinosaurs ruled the Earth for quite a long time until the asteroids struck the Earth. Um, it's not the asteroid mainly itself that killed the dinosaurs, but it's mainly the gases from the asteroid impact that blocked the sunlight, and it created this very dense air, so dinosaurs couldn't breathe. So it killed all the dinosaurs living on Earth. But let's look at this quick video about how this happened, and let's take a closer look at the Mesozoic era that we have here.
Probably.
Okay, yeah, so this video talked about the dinosaur ages and how some of them began and ended as well. Let's turn our head into the Ice Age, right? One of the more recent events that lasted a long time until recently. Right? Until very recently, the Ice Age dominated Earth. So during the Ice Age, there were a lot of mammals, right? And mammals were organisms that are the organisms that have babies and not eggs like humans. And mammals during the Ice Age included mammoths. These are mammoths. And saber-toothed cats, giant sloths, Irish elk, and mastodons. And there were more mammals, before and after the Ice Age as well. Um, but these are the primary ones that survived the parts of the Ice Age. And now finally, we get to the humans, right? In the Cenozoic era, the most recent era starting from 11,700 years ago until today, humans have traits like long limbs, short teeth. They use stone tools. They know how to utilize the stone tools by having larger brains. Humans walk in 2 feet. Right? They are bipedal. They have vertical faces, short jaws, things like that. And we all are humans. We are all humans, and humans are the most recent species called the Homo. And humans have went through evolution from 2 million years ago until today. And scientists believe that humans have a linkage, the past ancestry with monkeys, right? From the evolution theories. And again, this is one part of the theory as well that formed humans and who we are. But humans evolved to have more complex brains, to think, to critically analyze, and to walk in 2 feet. And again, this is the human development. You know, there was the Aphronesis stage. It's actually not a Homo at this stage. That's still considered an ape, right? At this Australopithecus stage. Australopithecus doesn't have the Homo as the species. So they're not really considering, scientists are not considering that as a human yet. But humans started with the Homo habilis, right? And then we went to Homo erectus. Then we went to Homo neanderthalensis. And then to our current human stage, which is the Homo sapiens. So we are currently Homo sapiens. And there has been development of humans across time as well. And again, across these human developments, our brain size increased, the neural connections increased, our ability to stand and to maximize tools increased, and we developed into human beings like we are, like everyone is on Earth. Every human is on Earth today. Yeah, so this is a quick sum up of the life development from the Earth, right? Life first started from a single cell, the microbes, remember, that created the oxygen. And then they went to the unicellular organisms, and they evolved into these long-finned or amphibians, reptiles, and more. And it formed a T form, it formed the dinosaurs, and it formed other mammals, right? From the other mammals that included apes, right? And then it developed further into Homos, Homo erectus, and we've seen Homo neanderthalensis too. But then our current humans species is called the Homo sapiens. It's what we are today. So this is the full human evolution explanation. But there's different theories about the creation of life and the development of life. We've talked about evolution, right? So far, we have only talked about evolution. But there is also a theory of creationism too. So evolution is a scientific explanation based on natural processes over time. But creationism is a belief and theory that life was created by a higher power. So, if you're Christian, Catholic, you believe that God created all life, and that is a part of creationism. Again, there are different theories and beliefs, but these ideas come from different perspectives. Science versus religion and belief. And people may choose to understand life through one or both viewpoints, right? So many people who are Christians believe in creationism, but develop through evolution. So you don't have to believe one or the other. You can believe both. Again, this was the evolution versus creationism. And yeah, I think that's all I have for today. Yeah, any of you have any questions for me? Um, feel free to ask. Yeah.
Any question? No. You have any question for me? Is that? Okay.
Please, how many planets have ring?
Oh, did you ask how many planets have rings? Sorry, did you say how many
Yes.
planets? Yeah, have rings. Yeah, so we can see, let me go back to
Ah.
yeah, so let me go back to this solar system slide. So you can see that Saturn has rings, right? But you can also see it's
Yes.
smaller than Saturn, but Uranus also has a ring, right? And you see the smaller ring for Uranus. It's also the case that Jupiter also has a ring, but it's not really a clear ring as a Saturn, And Neptune is also considered to have a ring, but rings are mostly, made out of particles, dust, and ice, right? So Jupiter, Saturn, Uranus, Neptune can all have rings. They do all have rings. But the most visible ring is the Saturn. The Saturn has the biggest ring. Yeah, okay, I hope that answered your question. And yeah, are there anything else? Any other questions that you would like to ask me today?
David.
Yes.
Okay.
Okay.
You want it to go back to where? Evolution and creation. So they want you to go back to the slide with the evolution and creation.
Oh, okay. The creation slide.
In that,
Yeah, I think it's this one, right? Yeah, let me know if you finish writing. Yeah, and ask me any other questions. Yeah. Yes. Um, yeah, are you finished with the writing? Yeah, no rush, but yeah.
They want you to go back to the types of dinosaurs.
Oh, the dinosaur slides? Let me, um, this dinosaur time? Or,
Stop.
yeah, are there, anything else that you want me to go back to or, um, any other questions? Yeah, so, everyone is finished with the slides. Okay.
Okay. All right. I think everybody is done. and I think we are okay with that
Okay.
summit.
Hmm. Got it.
All right. So next week, the next week lesson will be
Oh, I think let me double check on the topic for next week. Yeah, are there anything that the students want to learn about? Um, yeah, I'm happy to do any topic. Uh,
okay.
yeah, we can
So,
do more science
so
or technology or anything that the students are curious about.
all right then. Yes. Okay. So I don't know if you'll be okay with mathematics.
Oh, with mathematics?
Yeah.
Okay, yeah, we can
If
um yeah,
yeah, is that
yeah, I think we can do mathematics for next week.
okay? Okay. All right then.
Uh,
Okay, then I will see.
oh, actually, I think our mathematics lesson starts a little later. Um,
Okay.
but before mathematics, I just wanted to have um fun topics for students. If they're interested in anything, yeah, not to the core subjects like math and science.
What do you want? Any of your interest for next week? English. Which aspect? Okay. The picture is not the same as the it will be different. Yeah, okay. So Jabin,
Yes.
they are talking about English language if possible. That is the literature aspect, if you are okay with that.
Mm,
Or vocabularies too. The two, anyone you are conversant with.
yeah, because I think the vocabulary and everything um comes a little later. Um, but yeah, I'll try to make it a fun topic. Um,
Okay.
maybe learning more about um, we can do more about learning about um other continents maybe. Like we've talked about only Asia so far, so we can maybe talk about um North America or we can talk about um Europe as well.
That,
Yeah, if you're interested. Mhm.
that would be fine. So,
Okay. Yeah, that sounds great. Um, oh, also, I will be visiting Ghana um to I think the next Monday. So on
that's
starting
the
from the 15th. So I think I will be able to yeah meet
uh,
you in person. Um, yeah,
all right.
as well.
Love to have you around. Okay. So
Mhm.
that is it. We'll be what? Expecting you and see you on next week.
Yeah, I think I will be able to do a live lesson or something 2 weeks from
Okay.
today. Yeah, 2 weeks.
Right.
So yeah, that's great.
That's
And
fine.
yeah, then I will see you next week. And next week I'll cover um maybe some culture topics via
Okay,
Zoom.
all
Yeah,
right.
okay.
Okay, then see you then. Thank you very much for your time and for everything. God richly bless you. Bye. See you next week.
Okay, yeah,
Take
thank you
care. Bye
everyone for listening. Yeah. Mhm.
bye.
All right. Bye everyone. Bye.